Question 8 is coming from vectors. Two lines have these equations, and then they are saying that show that the lines are skew. Lines are skew if they are not parallel, they are not perpendicular. Parallel lines, if they are parallel lines, then the directional vectors have to be scalar multiples of each other. You cannot express this in terms of this one, so they are not parallel. Okay. Now let us see if they are to intersect. Okay, we use the concept of intersection. So we can say for intersection, that means this one is equal to this. So I'm going to use the parametric equations. This one will be -1, then plus 2 lambda, then 3 plus 3 lambda, and then -4 minus lambda. Then this one is equal to 2 minus lambda, then -3 minus 2 lambda, and then -1 plus lambda. So I can get two equations from here. I solve them simultaneously to get the values of mu and lambda. Then from there, I use the third equation to test whether it is satisfied. So I can take -1 plus 2 lambda, which is equal to 2 minus lambda. Now I'm going to take the third one because I'm seeing a lambda here, so I can easily subtract and lambda goes. So this is -4, then minus lambda is equal to -1 plus lambda. Actually, I'm not going to subtract, I can add because this one is a minus, this one is a positive. So we shall have -5, then plus lambda, then this one will be equivalent to 1. So meaning lambda shall be equal to negative. Actually, it is not a negative. When this one crosses, it's a positive. So 1 plus 5, that one gives us a 6. Now, we can substitute for lambda. So this one, if I substitute in the second one, that's -4 minus 6, which is equal to -1 plus lambda. So take this one here. This one is -10, then plus 1. That one will give us -9. So mu is going to be equal to -9. Now, I used the third one and the first one. So I need to test with this third one here. So we are going to have, using the second equation, here, we have 3 plus 3 lambda, which is equal to -3 minus 2 mu. So this is 3 plus 3 times 6. Is it equal? I'm asking myself to -3, then minus 2 times -9. This one is 18 plus 3, which is 21. And this one here is -3 plus 18, which is 15. Okay, so that one gives us 15. And these two are not equal. So the lines are skew. The lines do not intersect. Okay, the lines are skew. Since one equation is not satisfied, since one equation isn't satisfied by the values of lambda and mu. Okay, and the directional vectors are not scalar multiples of each other. So lines are not parallel. Lines ain't parallel. Part B, find the obtuse angle between the directions of the two lines. Now the directional vector for the first one is here, is 2, 3, -1, then the other one is -1, -2, 1. So I'm going to have 2 here, then 3, -1, and then the directional vector for the next one is -1, -2, 1. So we use the scalar multiple, the scalar product. So D1 dot it with D2, then this one is equivalent to the magnitude of D1 times the magnitude of D2, then cosine of the angle in between. So if I make theta the subject of the formula, I would first take away this one to this side, so I will divide all through. Okay, so I will have D1, then after that, by the way, I take the arc cos, so it will be the arc cos of D1, then dot it with D2, then divide by the magnitude of D1 and D2. Now we dot these ones, so we shall have 2, 3, -1, dot it with -1, -2, 1. Okay, then from there I forgot my arc cos. So from there, then we are supposed to take the square root, 2 squared plus 3 squared, then plus -1 squared, then times the square root of -1 here squared plus -2 squared plus 1 squared. So here we have 2 times -1, that is -2. So -2 here, then 3 times -2, that is -6, and then -1 times 1, that is -1. Out of this one will give us, this is 4 plus 9, that is 13 plus 1, that is 14. So that means here I'll have square root of 14. And then this other one here is a 4 plus 1 plus 1, that is a 6. So square root of a 6. So altogether, this one is -9, then over square root of 14 times the square root of 6. Now, since this one is a minus, arc cos of this one is going to be an obtuse angle. Okay, that is in the second quadrant where cosine is a negative. So what do we get here? Now, since they never specified whether the angle should be given in degrees or radians, I can put it in radians, so, or degrees, whichever you want. So shift arc cos, this is -9 out of the square root of 14 times 6, and this is 2.95 radians. That is to 3 significant figures. Or, but in the exam, you don't write this that I'm doing, that you say or, you just give one answer. Okay, so if I change it to degrees, what do we get? Just come to your calculator here, and then you press shift, then mod, change it to degrees, which is 3, press equals again. So that is 169.1. 169.1 degrees, that is to 1 decimal place. So that is what we are having here.